Eco-design, also known as a design for environment, DFE, is a design approach that seeks to minimize the environmental impact of a product or service throughout its entire life cycle. And this includes the extraction of raw materials, the manufacturing process, the use of the product, and its disposal. It is very important because it can help us to reduce environmental impact, conserving resources, and also achieving sustainability. In the context of a green building, eco-design principle can be used to create a building that are more sustainable and environmentally friendly. And some of the key principles of eco-design in green building include, the first one is in terms of selecting a sustainable material. A green building should be made with materials that have a low environmental impact, such as recycled materials, locally sourced material, and materials that are focused using sustainable practices. And secondly, it should minimize energy use. A green building should be designed to use as little energy as possible. This can be achieved through features such as energy-efficient lighting, insulation, and HVAC system. And also, it should be conserving water. A green building should be designed to conserve water. This can be done through features such as rainwater harvesting, grey water recycling, and low flow fixtures. And it should be promoting indoor air quality. A green building should be designed to promote a good indoor air quality. And this can be achieved through features such as ventilation, air filtration, and the use of a non-toxic material. It also should consider the surrounding environment. A green building should be designed to be in harmony with the surrounding environment, and this can be done by selecting materials that are native to the region, and it will minimize the impact on the wildlife and also protecting the view shed. Now we take a look on some examples of how eco-design can be implemented in a green building. So we know that using recycled materials like wood and concrete in construction can help the environment. So we try to use a more recycled material such as reclaimed wood and concrete to reduce the environmental impact of a green building construction. And also we try to design the building to maximize the natural light and ventilation, and thus it will reduce the need for artificial lighting and heating, and also cooling. And also we need to use non-toxic materials in construction and finishing if we want to improve the indoor air quality of the building. So here meaning that we use safe materials to ensure a better indoor air quality within that green building. And also we can use rainwater harvesting system to collect and store rainwater for irrigation and other uses. And also to generate electricity, we can install a solar panel on the roof and other types of other renewable energy system to generate electricity on site. If we want to design a green building, the design of the building should maximize natural lighting and ventilation, like what we can see in the figure here. And thus it will reduce the need for artificial lighting and also heating and also cooling of the building. And here in the figure here, we can see that an example of a building that made up from recycled material. This is one example of a building This is a micro library that located, situated in Bandung, that made from a recycled plastic ice cream container that used as a facade. So now let's talk about site consideration in the construction of a green building. So we need to choose a site that has the least environmental impact and maximize efficiency. So we can say that as site consideration in eco-design, it refers to the selection and analysis of a site based on its environmental, social, and also economic attributes. It is very important because a proper site selection, it can reduce a project environmental impact. It can help to improve energy efficiency, and it will positively affect the future inhabitants' well-being. So, in order for us to choose a site that has the least environmental impact, and if we want to maximize efficiency, the site should be locating near a public transportation, and we should use brownfield sites or previously developed areas, and also by minimizing site disruption, we can maintain the native vegetation. Site analysis in architecture, meaning that we study a place before designing a new building, and this includes checking the place size, shape, weather, and other features. And we also think about future changes like new building or new roads or nearby building and so on. Yeah. So the analysis needs to consider any future development or changes to the site surrounding, such as a change of road designation, changing cultural patterns, or other significant building development within the area. Information gathered from the site analysis is used to identify the opportunities and constraints of the site and help us to develop a design that respond to this factor. So site analysis help us see the good and bad parts of the place so we can design a building that fits well. Yeah. It is a very important or crucial step in designing building to make sure that they match the surrounding, because it can help to ensure that a new building is well suited to its site and surrounding. Choosing a site for development or construction with the least environmental impact while maximizing efficiency involve several key considerations. These considerations are aimed at reducing the carbon footprint, limiting damage to the environment, and also promoting sustainable development. And here is how each of the mentioned strategies contributes to this goal. The first one is locating near a public transportation, and also we can reduce carbon footprint and damage the environment using brownfield sites of previously developed areas, and minimizing site disruption, and at the same time we try to maintain native vegetation. In terms of locating near public transportation, we can help reduce the carbon footprint by encouraging the use of public transportation over a private vehicle. That will significantly help to lower greenhouse gas emission per capita. It can also help to reduce the reliance of fossil fuel and help to minimize air pollution. And also in terms of efficiency, it can improve efficiency where the sites near public transportation hubs. We can say that it is more accessible to a larger portion of the population. And this accessibility can lead to increased worker satisfaction, help to reduce the commute times, and a broader customer base for business. And secondly, in terms of using brownfield sites or previously developed areas, when we choose a brownfield sites of previously developed areas for any project, it helps preserve untouched landscape and the natural habitat. It helps to prevent urban sprawl and the loss of biodiversity. And at the same time, it also helps and promotes remediation. When we develop on brownfield sites, it often involves cleaning up and repurposing contaminated land, which can lead to environmental restoration and the elimination of hazardous material. In terms of locating near public transportation, we can help reduce the carbon footprint by encouraging the use of public transportation over a private vehicle. That will significantly help to lower greenhouse gas emission per capita. It can also help to reduce the reliance of fossil fuel and help to minimize air pollution. And also in terms of efficiency, it can improve efficiency where the sites near public transportation hubs. We can say that it is more accessible to a larger portion of the population. And this accessibility can lead to increased worker satisfaction, help to reduce the commute times, and a broader customer base for business. When we choose a site that has the least environmental impact, it will help to minimize site disruption and also maintaining a native vegetation. So we can preserve ecosystem. We can maintain the original flora and minimizing changes to the land, and it can help the local ecosystem. It can help to support biodiversity, the soil health, and also the water quality. Yeah, and also we can help to reduce landscaping need. When we keep a native vegetation, it can help to reduce the need for landscaping and irrigation, and this will lead to a lower water usage and a decreased maintenance cost. When we have a native plant in our site, it will help the environment, and it is more resistant to local pests and disease, and it will further minimizing the need for a chemical treatment. Reducing consumption and increasing efficiency in energy and water use are very essential strategies for sustainable living and environmental conservation. So implementing these strategies not only help in minimizing the ecological footprint, but also leads to significant cost saving over time. So how can we reduce consumption and increase efficiency? Maybe in terms of energy, we can implement a solar panel, wind turbine, or other renewable sources. To reduce water usage, we can apply low flow fixture and use efficient irrigation system. And for us to reduce energy consumption, we can use Energy Star rated product appliances that can help us in reducing electricity usage. From the figure here, we can see some specific ways to improve energy efficiency in green building. Like what I have mentioned just now, we can use energy efficient material and appliances. And this includes things like choosing a light colored roofing material that reflect heat. We can also install insulation in walls and ceiling. And we can use energy efficient appliances such as LED light, a bulb, and also Energy Star rated appliances. Also, we can design a building to take advantage of natural light and ventilation. This can help to reduce the need for artificial lighting and heating and also cooling. Yeah, and if possible, we try to use renewable energy sources, and this, like what I have mentioned previously, it could include a solar panel, a wind turbine, or in depending on the geographical location, we can apply or we can use a geothermal heating and a cooling system. The characteristic of a green building is the application of a natural lighting. Yeah. So we want to use sunlight to reduce the need for artificial lighting. So in order to achieve natural lighting in green building, we can use a skylight, we can install large windows, and also we can apply or we can use a light shelf. We can also design our space to capture and distribute sunlight. This is very beneficial as it helps to reduce energy bills, and also it can provide psychological benefits to humans. Not only it can reduce energy bills, it can also provide psychological benefit such as improving our mood, reduce stresses, and also increase productivity. Yeah, emissivity glazing is a type of glazing that reflect heat back into the building, which can help to keep the building cooler in the summer. It is a key innovation in energy efficient window technology. It involves coating the glass with microscopically thin, the transparent layer of metallic oxide. And this coating is designed to minimize the amount of ultraviolet in and infrared light that can pass through the glass without compromising the amount of visible light that is transmitted. And here are some benefits of low emissivity window. The first one is in terms of reflecting infrared light. Yeah, this low emissivity window, it can reflect the infrared light, and as a result, it will reduce the heat gain, and this can help to keep interior temperature cooler during summer months in temperate climate. And secondly, it can help to block UV rays, and it can block the most ultraviolet UV light, and as a result, it can protect interior decor from and materials from fading due to UV ray. And the third one is in terms of temperature regulation. This type of glass, it helps to reflect heat away in summer, and as a result, keeping the building cooler. It reflects heat inward in winter in temperate climate, and as a result, help to reduce heating that needed. In terms of design strategies and tools, this is how we can implement natural lighting in green building. The first one is in terms of windows and glazing. We can use high performance windows and glazing system that can allow daylight in while minimizing heat gain and or heat loss. We can also use a skylight. These are the openings on the roof that allow sunlight to penetrate deeper into the building. And also we can use a light shelf that is a horizontal structure that placed outside or inside windows to reflect daylight onto the ceiling and deeper into interior spaces. And also we can use tubular daylighting devices. And these are tubes that can help to capture sunlight from the rooftop and direct it to the interior spaces. And also we can use solar shading devices. This help to prevent excessive sunlight, which could lead to overheating and glare, and as a result, it helps to enhance comfort. Now we move on to natural ventilation. Natural ventilation utilize environmental condition to reduce our reliance on mechanical system to ventilate a building. This is a very important characteristic of a green building because not only align with sustainable building practices, but at the same time it helps to enhance occupant comfort and well-being. Yeah. So our objective here is to use a natural process to reduce the need for mechanical ventilation. We design the building for cross ventilation, and this includes the operable windows, louver, and vent. As a result, we can get fresh air, we can reduce energy bills, and enhance indoor quality. Buildings are designed to encourage airflow from one side to the other, and this often involve aligning windows and doors across the opposite wall for us to facilitate the movement of air throughout the interior spaces. And also, in terms of environmental consideration, the design takes into account the dominant wind direction and use them to maximize the airflow within the building. To achieve natural ventilation, we can use operable window. Operable windows are types of windows that can be opened and closed, and thus allowing occupants to control the flow of fresh air into the building based on weather condition and personal preference. And also we can use louver. Louver is adjustable type of window that can help to regulate both the direction and the amount of airflow, which is particularly useful in areas with variable wind condition. And also we can use fan. Fan is strategically placed to help in drawing air to the building, even in the absence of wind, by exploiting thermal buoyancy. Hot air rise and escape to the higher vent, and at the same time drawing cooler air in through lower opening. Yeah. In the figure here, we can see different types of ventilation. We have a cross ventilation here, and also we have a single side ventilation, and also we have a stack ventilation. The first one is the cross ventilation. This is when the wind blows through the windows on the opposite side of the living room, and as a result, it will bring in fresh air from the outside and pushing out the stale air. And then we have here single side ventilation. This is when the wind blows through the windows on one side of the living room, bringing in fresh air from the outside and pushing out the stale air through the other openings on the same side, such as a door or another window. And here at the bottom, we have a stack ventilation. This is when the warm air in the living room, it rise up to the chimney and exit to the top, drawing in air cooler from the outside to the window. Again, when we use the natural airflow wisely, it is a very important aspect for eco-friendly building. It helps to save energy and keeps people comfortable. Just like any building or any design choice, it should fit the building, the people in, and the surrounding. By using natural ventilation, we minimize reliance on air conditioning system and fan. We can also improve indoor air quality by bringing in fresh air and expel pollutant and stale air. We can reduce the risk of sick building syndrome. That is the condition that caused by a poor indoor air quality. And finally, by using natural ventilation, we can help to mitigate greenhouse gas emission. We reduce our dependence on mechanical system indirectly. It will help to reduce the emission associated with electricity production.